Off the project, I started with brief requirement 1. I selected the Valorant Champion Tour 2021 to 2024 data from Kaggle.com. As a quick intro to the topic, Valorant is a free-to-play team-based shooter game with matches consisting of 2 opposing 5-player teams. The dataset is reliable because it's taken from Valor.gg, a widely recognized and publicly accessible Valorant statistics website that compiles data from official esports events and organizations. To clean the raw data, I first looked at the dataset structure. The dataset contains data from 2021 to 2024, split into multiple CSV files. I focused on agent pick rates, attacker and defender side win rates, and win/loss methods counts, cleaning and concatenating them into a single dataset. Using the pandas library, I reformatted values, removed unnecessary data columns and rows, and stored the data into a dictionary in preparation for the analysis. I started with the agent pick rate data. With computational thinking, I developed an algorithm and created a section of code that used the drop function to isolate the data with the attribute all match types, and I abstracted the dataset to highlight the necessary data columns. Using pattern recognition, I found that I could repurpose the code for the other 2 cleaning stages. I then sorted all 3 sets of clean data into data frames and wrote them to concatenated CSV files. This is what the first CSV data looks like now compared to before. To hit brief requirement 2, I used Python statistics library with nested loops, if logic, and min and max functions to calculate key metrics like mean, median, mode, and range for the first key aspect of the dataset. Through pattern recognition again, I manipulated this code to analyze the 2 other key aspects of the dataset, storing the results in a dictionary. To create 2 basic visualizations, and after noting that we needed to add interactivity to these graphs for advanced requirement 1, I decided to use Plotly to create these graphs. These included a bar chart, polar graph, and pie chart of the 3 key aspects, each exported as an HTML file. I used a nested loop and a trace indices list to display the traces for every agent's data each year for the horizontal bar chart. This code shows the creation of the axes, titles, and legends. These are the output graphs. Hitting brief requirement 3 prompted me to develop an interactive information system interface with HTML, CSS, and JavaScript. The homepage features information for the public about my dataset and the topic. Throughout the website, superscripts are also present to help the user understand certain terms relating to the dataset, providing a sense of interactivity and ease of use. The graphs.html page displays all of the data visualizations I've created by pulling the graphs as HTML files into iframes on the webpage. This is done to integrate the interactive features of the graph for advanced requirement 1. The interactive features include the on-hover elements, click to filter data dropdown, and trace visibility toggles. To hit advanced requirement 2, I created another web page called poll.html with the HTML form element to take in 3 different types of inputs, those of which are a string, integer, and boolean input type. The 3 questions asked were about the user's favorite team, their prediction of the team's next placement in the tournament, and if that team will win the following tournament. After this, I created a JavaScript file to connect to Firebase's real-time database. I created a save all data function to push all 3 inputs into the database, as you can see now. To validate the data, I use if-else statements in the JavaScript function to determine whether all the boxes are empty and if the integer was a negative number. In summarizing the collected data, I created a create table function to pull the data back from Firebase and display it into a table element in HTML. Let's input some values into the form. If I scroll down, you can see that the values have appeared at the end of the table. Over in the Firebase, you can see that it's saved under the node users with a unique user ID. Hitting advanced requirement 3 required me to create another section, which I did in the form of another web page called recommendations.html. I suggest 4 main improvements based on my analysis. To create this HTML file, first I had to head back to the Python file and import the JSON library, allowing me to write the dictionary of data analytics to a JSON file. I created the fetch data function to pull this data, with the local server running, and then use for loops and if-else logic to create recommendations for the user. Let's take a look at the front end. As you can see, it seems that Jet is the only agent with an average pick rate of over 60%, so the suggestion is to pick this agent. The other suggestions implemented included the best maps for defending and attacking based on an average win rate of over 50%.